So selection of the root attribute is the attribute selection process, and for that we are having three measures. And in the last class we have discussed about the information gain. So what is the information gain? It measures the quality of the split. So before going further, first need to discuss about the entropy. So entropy is nothing but it is the measure of impurity or uncertainty, or also called measure of variance in the presence in the data set. So we are having certain formulas for entropy and information gain. So information gain can be obtained by subtracting the entropy of the entire data set. Sorry, subtracting the entropy of a particular split based on an attribute from the entropy of the entire data set. So that difference we will get in terms of the information gain. We also call that value as the variance we have reduced by selecting the particular attribute, say for example age or income, whatever. So let's go back to the PPT. So here in the last class we have also discussed some examples. We have done an exercise on information gain. Is my screen is visible?
Yes, ma'am.
Yes, ma'am.
Thank you. So we know that this is the formula for the entropy, and with that we have taken a sample data set, and we have made some calculations how to. So I hope everyone is now clear about how to calculate the entropy for a data set, entropy for the split, and also how to get the information gain. So here, by subtracting the entropy of a split from the entire entropy of the data set, we will get the information gain. And after that, the attribute with the highest information gain is selected as the root attribute. For example, in this, we have information gain for the age is obtained as 0.246, whereas if you obtained information gain for the remaining attributes is less than the information gain of the age. So we can select the age as the root attribute in the first iteration or in the first level. So that's why we have selected here age as the root attribute. So next what to do? So when next we need to consider the values of the age. We have three values of the age: youth, middle age, and senior. So after that, the data set is divided into or partitioned into different parts based on the number of values. So in this example, the data set is partitioned into three partitions. So here is a question. Again, at this stage, what is the root attribute? So whenever the age is selected as a root attribute here, it should be removed from the list of all attributes. So now we are having some list of attributes other than age. So again here at this stage, what we need to do? Again, we need to perform some we need to again go for the attribute selection method. Again, we need to apply the information gain procedure. Entire thing you need to go, and after that, here in this example, student is selected as the next best attribute out of all the present attributes of the data set other than age. So like this, we need to grow the tree. So this is the process of decision tree induction. So if at all they are asking for decision tree induction, you need to write the algorithm and you need to explain that, and you need to mention the measures. If at all they are asking for any specific measure, you need to go through that measure along with this example, which we have discussed yesterday. And here is a summary of information gain. So here we have selected the age as the best attribute for keeping as a root. So this makes sense. Why? Because higher information gain indicates that smaller the entropy. That means we are removing the more entropy. Smaller the entropy in the sense, smaller the variance. So if at all the particular data partition having the less variance, which indicates that that is a pure partition. So which we actually want. So which is what we want, and in the perfect case, each branch would contain only one class after the split, which would be zero entropy. So coming to the summary point of the information gain, the process of constructing decision tree from a training data set is done by evaluating the information gain of each attribute and selecting the attribute that maximizes the information gain. So which in turn minimizes the entropy. See, entropy and information gain are completely inversely proportional to each other. If there is a high entropy, it results in low information gain. If at all there is a high information gain, which means that there is a low entropy of the data partition or the data set. And best splits the data set into groups for effective classification. So here information gain is the amount of information that's gained by knowing the value of the attribute. So which is the entropy of the distribution before the split minus the entropy of the distribution after it. We already talked about that, right? And coming to the drawback of the information gain, the main drawback of this is it is biased towards the multi-valued attributes. That means if at all your data set consisting of the attributes, out of all attributes, if a particular attribute having multiple values. So what is the example of that from our data set? What is the attribute having too many values compared to remaining attributes? Can anyone tell me? Here is the data set. So in this data set, what is the attribute which is having too many values compared to other attributes? If at all I got late response, I need to call upon the numbers. So if you want to secure your friends, you just whoever know the answer, you can speak out. What is the attribute with what is the multi-valued attribute here? That means the topmost multi-valued attribute having too many values. Open up. ఇంకా నిద్రపోతూనే ఉన్నారా ఏంటి? What is the multi-valued attribute here?
Base computer, ma'am.
Base computer consisting of only two values, yes and no. Is there any any yes? Ceci చెప్పండి.
Age, ma'am. 3.
Yes, age is a multi-valued attribute here, and also income.
Income also, ma'am.
Yes, are unde kada. Why? Because if you go through the remaining attributes, students consisting of only two values, credit rating consisting of also only two values, fair and excellent, and even class bias computer also consisting of two values. So here purely the multi-valued attribute, that means which is having more than the number of values compared to the other attributes is age and income. So what is the problem in information gain is it is biased towards selecting the multi-valued attribute. So if at all any multi-valued attribute is there in the data set, it directly selects it. Even though you need to go through all the process of calculating the entropy and information gain, but ultimate result is it automatically selects the attribute which is having the multiple values. That means it obviously selects either age as income. Sorry, either age or income. If at all, even though you go through all the procedure of calculation. So if at all you have the item data set, for example, if at all you are having the item data set, in item data set, one of the attribute is product ID. Actually, product ID is completely mostly product ID consisting of distinct values. Why? Because if at all in a store, roughly, if you think that there are some 500 items in a store, so if you have a database of the products in that store, so each item have its unique ID, right? Like each of the student have unique roll number, right? Like that, each of the item has unique ID. So if at all you're having the product database, that means which represents the list of all products exist in that store, in that departmental store, then what happens? The attribute which is having multiple more number of values is ultimately the product ID, right? Why? Because out of 500 items, all items have distinct product IDs. So that for a product ID attribute consisting of 500 different values. Suppose the product of first item, ID of first item may be A1, second item may be A2, third item may be A3, like that. Again, B1, B2, B3, like that. We are having 500 different IDs are there. So what happens if you apply? That means if you select information gain as the attribute selection measure for such kind of data sets, what happens? Automatically, even though by going through all the process, automatically it selects the product ID as the root attribute. then what happened? The width of the decision tree is increases drastically. Are you getting my point or not? Let me. So if you suppose if you're having that um, database consisting of some product ID and some product name, price, like this we are having. So out of all the attributes, what is the attribute consisting of too many values, too many distinct values, is obviously
Product ID.
yes, just like our example. So by going through, if you have selected gain as the attribute selection measure for this kind of data set, what happened? IG automatically selects product ID as the root attribute. So this is placed as the root attribute. Then what happened? Consider your size of the data set is 500 into some 4. 500 rows you are having in that data set. We have 500 product IDs. Then we need to take how many branches? How many branches we need to take from this? 500 branches we need to, yes, 500 branches we need to take. Then what happens? The width of the tree is drastically increasing. Of course, it divides the data set into 500 partitions, where each partition obviously holds only one tuple. Of course, it results in fewer partition, even though it results in fewer partition, but it is not useful for the proper classification. Because this is all we are doing is for making the good classification, because we are in the concept of classifier and decision tree is one of the classifier. So such kind of classification is not required here. So that's why we are moving for the next measure, that is information gain ratio. We are moving for the next measure, that is information gain ratio, which actually uh, bypasses the problem of this biasing towards the multi-valued attribute. It is treated as a normalization to the information gain with some splitting criteria. Let me explain that here. Here is the information gain ratio. So here, look into the screen here. C4.5 uses information gain ratio as a splitting criterion. Wait for a second. C4.5. What is the C4.5 and ID3 and cast? Initially, I told you in the introduction of the decision tree. So we are having 3 algorithms for the decision tree. The first one is C4.5 and the next version of it is ID3. Sorry, first one is ID3 and next version of it is C4.5, and after that we are having cart. These are the different versions, like different algorithms in the decision tree. So initially we are having information gain, which is used by the algorithm ID3. And after that, the extension of that measure is nothing but gain ratio, that is used by C4.5. So this algorithm uses gain ratio as a splitting criteria, and this measure comes as an extension of information gain. What is the purpose of entering into this method is to reduce the bias towards the multi-valued attributes by taking the number and size of branches into account and choosing the attribute. And it corrects the information gain by taking the intrinsic information of a split into the account. What is that intrinsic information? We will see later. So information gain ratio, this is the formula for that information gain ratio. First we need to, for this also we need to calculate gain. Information gain we need to calculate, and we need to divide that with the intrinsic information. This is called intrinsic information. Here, yes, here intrinsic information is represented in terms of split information. So information gain ratio is the ratio of information gain to the intrinsic information. So this is the formula for that. And it applies a kind of normalization to information gain using the split information value, and this split information value, this split information value is obtained like this. So what is this normalization, kind of normalization? Generally, I told you the normalization is nothing but scaling the values to the specific range. How to normalize that? If at all I'm having some 100, So if I ask you to normalize into the or otherwise I'm having some value as 70. If I ask you to normalize it into the scale of 1 to 10, what is the equivalent value for this? Obviously 7. So how to get that? Performing some divisions. Performing some divisions with respect to 100, we will get some normalized value. So here also we are dividing the information gain with the split information. So which is represented as a kind of normalization here. Okay, and this value of the split information represents the potential information generated by splitting the training data set D into V partition, corresponding to the V outcomes of the test on the attribute. And note that for each outcome, it considers the number of tuples having that outcome with respect to the total number of the tuples, right? Here, for each outcome, we are considering the number of tuples with having that outcome. That means D, suppose this is, let's say this is D1. So D1 is the data set of the partition 1. That means it may be the result of one outcome. And here D2 may be the result of another outcome. D3 may be the result. In the last class, I told you, right, when you have considered A as the root attribute, and if its value is youth, we have the partition called D1. If its value is middle age, we have partition called D2. Its value is if its value is old age, we have a partition called D3 like this. That means for each outcome, we have a partition. And in this formula, what we have considered, the number of tuples in that partition. So always mod indicates that number of tuples in that particular data set. It is a ratio of that to the total number of tuples in the entire data set. So that is what here telling. So for each outcome, it considers the number of tuples having that outcome with respect to the total tuples in D. So information gain ratio differs from information gain, which measures the information with respect to classification that is acquired based on the same partition. The attribute with the maximum information gain is selected as the splitting attribute. Here also the same story. So in case of just like the information gain, so in information gain, the attribute with the maximum information gain is selected as the splitting attribute. So here also the attribute having the maximum information gain is maximum IG ratio value is selected as the splitting attribute. And here just we have done in the last class, here also we need to calculate information gain ratio for one attribute. That calculation I will show you with the same example. And listen carefully. I'm going to divide you people into 3 groups from from 1 to A4. You are having right numbers from 1 to A4. Those total people are divided into 3 groups, and we have 3 problems need to solve. So I will hand over each problem for each group. Problem of calculating the information gain ratio for a particular attribute. I will assign each of that problem to the each team. I don't know who solves the problem from team. Maybe all team together solves the problem, or one from that team solves the problem. I don't bother. So for my next class, that is for the Saturday 3rd hour, we are having my class, right? So for that class, I just call the team and I need to have the answer from that team. I need to have the information gain ratio value. And if at all, I have asked some process also how to calculate that. The one who answers that, you need to explain that also. If at all I have any doubt whether they are really calculated it or not. So if at all that is correct answer, the whole team will be provided some attendance. Otherwise, I won't give attendance. So this is the same thing repeated in every class. Class అయితే అటెండెన్స్ పోయినా పర్లేదు అనుకోవచ్చు, ప్రతి క్లాస్ లో పోతుంది అంటే మీకు ప్రాబ్లం ఏంటి. సో యూ హ్యావ్ టు పే సమ్ అటెన్షన్. That is the ultimate aim. So listen carefully. I'm giving some kind of assignment. Assignment is not writing something by copying from others. That is not assignment here. Here only the assignment is I'm going to explain how to calculate the information gain ratio for the given data set. I will calculate for one value, one attribute, and for the remaining 3 attributes, the 3 groups have to be calculated. One attribute for each group. So pay attention at least from now onwards. So So whoever are listening from the beginning, I appreciate that. So I'm telling to the entire class. Okay. So here the attribute with the maximum information gain ratio is selected as the splitting criteria. I have taken some attribute A's I have taken. So for A's, I will give you all the calculations, how to calculate that, etc. And for the remaining attributes, you people should come with the value. And by comparing those values, the attribute which is having the maximum information gain, that is selected as the that is selected as the splitting attribute here. So that is selected as a splitting attribute here. Okay. And here is an example. We have considered the same example. For calculating the information gain, first what to do? We need to have the gain of A. So we are having all these values in the previous slides itself. So we have calculated gains of each value. Gain of age is there, gain of income is there, student is there, credit rating is there. So no need to calculate this again. Our task is just to calculate this split information. And here is the formula for calculating the split information. And before that, we just have a table to get to get the error-free result for our convenience only. So what are the values for income? What are the values for income we are having?
High, medium, low, ma'am.
Yes, high, medium, and low are the values for income. And how many S's are there? S classes for high. How many S classes are there? 1, 2.
2, ma'am.
2, ma'am.
Yes. Here is 1. Here is 1, right? How many no's are there?
2, ma'am.
Cross check చేయండి మిగతా all కూడా whether the answer is right or not, like that. Next, coming to the medium, how many S groups are there? S tuples are there?
3, ma'am.
3. And next, how many no tuples are there? How many no tuples are there?
2, ma'am.
Yes. Next, how many low out of all low tuples, how many S are there?
3, ma'am.
4, ma'am.
3 or 4?
4, madam.
4? Confirm చేసుకొని చెప్పండి. Low tuples కదా. So 1, 2, 3, 4. Out of 4, how many S are there? I'm asking.
3, ma'am.
So 3.
3 yes,
Number
1
20.
no, ma'am.
Yes. Number 28. Are you getting this point or not? So out of 4 is the nothing but all the low tuples we are having 4. That means we are having 4 observations with the value low. Okay. Out of 4, how many are having the class label as S, and how many having the class label as no? We need to consider here. So total 4.
మేడం ఎస్ లో 4 ఉన్నాయి కదా మేడం లోకి.
లోకి అసలు 4 ఉన్నాయా? లెట్ మీ చెక్. సో హియర్ ఈజ్ ఎస్, ఇక్కడ లేదు కదా. We are having no. The ultimate class label we need to consider, not student or credit rating. Okay.
Ma'am, medium
Is
S
it
లో
clear?
4 ఉన్నాయి, ma'am.
Let me cross check. Here, A column doubt meeku, second column or third A row doubt ko undi. Is it clear with the first row?
Madam, medium SL4, ma'am.
Medium S4.
SL4.
And no classes? No classes for
No,
medium.
ma'am.
3, madam.
Total 6.
Let me check. So for medium, here is an S class, and here is an O class, here is an S class, 2, 3, 4 S classes, right? For medium, okay. 1 no class, I think. Only 1 no class we are having, right?
14th one ఉంది కదా మ్యామ్. నో.
Okay.
2 no class.
Yes. Is the total ఎంత ఇప్పుడు? 6.
మేడం ఫోర్త్ కూడా ఉంది కదా మేడం. ఫోర్త్ మీడియం నో ఉంది మేడం.
Fourth the medium yes kada. Fourth one. This is medium and this the label is no. Sorry, the label is yes here. Antena? If you consider the fourth line or fourth observation, here the income value is medium. Yes, yes. Next, is this right or no? Totally, we are having 4. Saripayini kada? Because we are having totally 14 observations. Here, it matches with it, right? So, from this data, we need to apply here. So, just first expand this. Since we are having 3 partitions, we need to expand it in 3 steps. So, minus of D1 partition and length of D into log 2 D1 partition length of D. Similarly, D2 partition length of D log 2 D2 partition length of D. And similarly, we are having what? D3 partition length of D log 2 D3 partition length of D. So this is for entire thing. So just substitute this. How many tuples are there in D1? This is D1. What is D1? This is D1. This is D2. This is D2. How many tuples are there in D1? Total tuples.
4, ma'am.
4. Out of 4, how many tuples are there in D? D is nothing but this is D. Total data set. 4. Right? A big minus is there in front of this. 14 log. Again 4 by 14, right? 4 by 14 plus. Next, coming to the D2. How many tuples are there in D2?
6 madam.
6 by total 14 we are
14.
having. Yes. Again 6 by 14. And next, coming to the third partition. You need to respond.
14, ma'am.
What figure
4
I
by
need to
14.
What? 4 by, yes, 4 by 14 log 4 by 4. So we need to get this. Are you with calculus or what? So here is the answer, 1.557 bits. This is what? This is a numerator value or denominator value? We are getting some value as 1.557. That is numerator value or denominator value?
Numerator value.
Denominator
value,
Yes.
ma'am. 15.
Denominator value. Numerator value is here. This is the formula. Here is the formula. In numerator, we are having gain of A. That is already calculated in the last class. We can directly take that value. Now we have calculated the split information, right? We have calculated the information. So what we get is 1.557. So for getting the gain ratio, we need to, what we need to do? Gain of A, we need to take from the past value, gain of A minus this 1.557. So if you do that, you can get some value, which is nothing but the gain of what? Income, which is nothing but the gain of income. So let's go back to the previous slide. Here, you can note down these values. Gain of income, for my case, because I have considered income as the first attribute, I have did all the calculations for the income, so I need to take this value only. Whereas from your case, you need to record these values, note down these values. Why? Because you need to do for this. So what is this value? Gain of income 0.029. So what to do now? 0.029. So I need to just information gain ratio is equal to ఎంత వచ్చింది ఇందాక 0.029. Yes. 0.029 by what value we get just now?
1.557.
1.55. Yes, the value is 0.029. Here is the value. For the sake of understanding, I will clear. Okay. Hope this is. So here is the value. What is that value?
0.029 మేడం.
0.029. ఎలా వచ్చింది ఇది? Just by dividing the split information value, which we got as 1.557 with the gain value of income. Gain value of income we have taken from the previous class session, because in the previous class section we have different values. So now it's time for assignment, announcing the assignment. Just wait for a while. So here the third one is Gini index. Here the third measure is Gini index. So I think, okay, in this class I have just briefly giving the idea, and in the next class I will explain about the Gini index more. So Gini index is the third measure, okay, and its purpose is to measure the impurity, just like information gain. Where here we are having Gini index. So here it is used in CAST, whereas two previous measures are used in ID3 and C4.5, whereas this Gini index is used in SART algorithm. So here, just like entropy, here also we are having some values. Let me first note down the values for entropy. So entropy of the entire data set is, we already know that I'm just rewriting this. I is equal to 1 to n ps log 2 ps, and entropy of the split is minus sigma j is equal to dj by d. And from this we can get gain value as this is all we know. Entropy of the entire data set minus entropy of that particular attribute. Entropy of that particular attribute. So just if you remember these formulas, we can easily go for the Gini index. You can easily go for this. One minus sigma I is equal to 1 to n pi square. So this is equivalent to this one, Gini index of the entire data set is that. And next, consider the Gini index of the split. This is the Gini index of the split. So just like this. So if you observe what is the difference, actually here we have taken the sigma. Instead, we have only taken the two-step derivation we have taken. Why? Because the major difference of Gini index over the other is it only allows the expansion of a binary tree. It doesn't allow expansion of other trees. Since it only allows the expansion of binary tree, only 2 branches are allowed to grow from the each root node, right? So if at all we are having root nodes, at every stage only 2 branches are allowed to grow. So what happened? Only at every stage only 2 partitions we are having. That's why since we are having only 2 partitions, this formula is expanded in 2 steps only. Whereas in this case, in general case, we may have more than 2 partitions. That maybe depends upon the number of values for that attribute. So because of that, we are having too many partitions here. That's why we have used sigma here. We don't know in how many steps we are going to expand this formula here in case of information gain. Whereas in case of Gini index, only 2 steps. In only 2 steps we can able to expand the formula. Why? Because it only allows binary trees to grow. Binary trees to grow up. That means it only allows a single split. Only allows a single split of the data set. If at all the data set is split at a particular place, obviously 2 partitions are resulted from that. It doesn't allow 2 partitions. That's why here we have expanded this formula in 2 steps only. Then after that, how we gain this for this one? So this formula is equivalent to this one in information gain. This is IZ. This is Gini index, and this one is equivalent to this one. And what is this? The total entropy we have reduced. That means total variance we have reduced from the data set. So here also total variance we have reduced from the data set is. So how can we get Gini index of the entire data set minus Gini index of the split? So just like that. Here we have expanded the formula like this: entropy of the entire data set minus entropy of the split. So here also we are having Gini index of the entire data set minus Gini index of the split. So this formula minus this formula results into this formula. Here also this formula minus this formula results into this. So here 2 things are raised about the Gini index. The first one is it is used in CART algorithm, where the remaining where the information gain is used in ID3, whereas information gain ratio is used in C4.5. Like this, here it is used in CART. And after that, it only allows a single split, means it only allows a binary tree to grow. That means it only allows 2 partitions from each root node. That's why here we need to expand this in 2 steps only. So this is a brief introduction about the Gini index, and I will explain in depth into that in the next class. So what's your assignment for the next class? The 3 teams from 1 to 40, 41 to what? 1 to 40. So whatever the 3 teams I have 1 to 40, 41 to 70, and 71 to A4 have to come with that information gain ratio values for the next class. Okay, I'm going to wind up this class. Thank you.